Hi, welcome back. In this video, we're going to go over the equation for heat and how to calculate how much heat is absorbed or released in a reaction given some variables. So we need to know what this equation means. Q equals mc delta T. Q is the symbol for heat, and we measure that in joules or kilojoules. M is mass, and mass needs to be in grams. Delta T is the change in temperature, so it will be T final, the final temperature, minus T initial, the initial temperature. C is equal to the specific heat of the substance that you are working with, and that is unique for every substance. Those values you would find in a table, or you might rearrange this equation to solve for specific heat. The units are joules per gram degrees Celsius. So the specific heat is the amount of energy it takes to raise the temperature by 1 degree Celsius of 1 gram of a substance. And again, that's unique for every substance. You might remember water is 4.184 joules per gram per Celsius. And let's practice using this formula. Let's say we want to know how much heat is released when we cooled iron from 50.4 degrees Celsius to 25 degrees Celsius. So let's say we're working with a 10.0 gram sample of iron, and we changed the temperature from 50.4 degrees Celsius to 25 degrees Celsius. We also need to know the specific heat of iron, and we could look that up in a table. The specific heat of iron is 0.449 joules per gram times degrees Celsius. So all we have to do is plug all of this information into this equation. And this is an example of what my chemistry teacher would say is a plug and chug equation. You have everything that you need, you plug it into the equation, and you're done. Super easy. So Q, the change in heat, is equal to 10.0 grams times T final minus T initial. So our final temperature was 25.0 degrees Celsius minus 50.4 degrees Celsius times the specific heat of iron, which is 0.449 joules per gram degree Celsius. We have 10 times negative 25.4 times 0.449 joules per gram Celsius. Our units of grams and Celsius cancel out because we have those on the top of a fraction and the bottom of a fraction. We're left with joules, which is what we want for heat. So multiplying all of that together in our calculator, we get negative 114 joules. This negative sign means that this was an exothermic reaction. Energy was released. If that were a positive value, then it would be an endothermic reaction. Energy would have been absorbed. So that's how you use the Q equals mc delta T equation. And of course, you can rearrange this equation to solve for any variable that you might be looking for. I hope this was helpful. Thank you so much for stopping by.